everyone, this is the demo video for Parky's smart parking system. And our team member is King Pang, Xiaofeng Pan, and Xinxin Jiang. So the first part of this demo video, we basically have some feedback of our Parky's system survey. So we conducted a potential user interest and feature priorities survey about this system. And we also have some key findings indicate that there's a high demand for real-time spot detection and vehicle location services about the parking system. And this is the survey, some of the questions we have on that survey, and this is the responding results of our survey. These screenshots is actually taken from earlier time. We have more results than this. And besides the survey, we also did some background test. And we have gathered some news and some websites to show that Americans have wasted 73 billion per year just looking for a parking spot. And we also have some findings like nearly half of Americans consider parking their car to be a stressful event. We have dig deep into all of these news and etc. to show that there's a great demand on this system. And this is an overview of our system. So basically we'll have a car spot finder which will take in users to find a spot, which means that it could return the nearest vacant spot to the entrance. And then it also, based on users' requests, have a find a car, which could locate a vehicle based on the license plate number and provides the spot location. We'll also have exit detection, which means that it can detect a car on exit and corresponding the information with the pallet number, and also record the time of the car has parking on this spot, which will give us the total fee of that users that need to pay. And we also have a timer, which will use by the car spot finder to monitor the duration of vehicle parking occupancy. And we also have, we're gonna store all the data we have to our SQL database, which is on the cloud platform. We will have the parking lot ID, the spot ID, the spot location, the car plate number, start time, end time, and address, and etc. to store in the cloud, which will help us to locate the car and help us to calculate the fee we're gonna have.
So for the parking spot setup, for the equipment, each parking spot is equipped with one ultrasonic sensor or IR sensor, and also a Raspberry Pi with one camera sensor, and IR sensor and also ultrasonic sensor is used to detect the vehicle presence, and the cameras is used to capture license plate image. So the working principle is like this. First, we use ultrasonic or the IR sensor to detect if there's a vehicle occupying the spot or not. If it is a vehicle there, it will trigger and return to the no red in our gateway, and which will also trigger the Raspberry Pi's camera to take a photo. And then it is the image processing step, which is to run the computer vision model. To be specific, is yellow model on the Raspberry Pi to exact the vehicle's license plate number. And then after that, we will do data transmission to AWS based on the start time of parking, also the license number and the parking spot location, and record that to our database. And this is how the ultrasonic sensor looks like. This is how the IR sensor looks like, and we already ordered it last weekend. And then for the AWS cloud implementation, we plan to create a database, a SQL database on AWS to store different information for later data analysis. So the information we will store is that a parking lot ID to store different parking lot that use our service, and also for each parking lot, it will has a parking lot address and also occupation rate. And for each parking spot in the lot, we have a spot ID which provide identification for every parking spot within the lot, and also the spot location so that we can record which vehicle is located and also the location of the spot, and also the plate number. So if the parking spot is vacant, we will leave none to the plate number. Otherwise, we'll just input the vehicle's plate number to it. And also the start time and the end time for the spot to record, so that we can know how long is the corresponding vehicle is using the spot and calculate payment based on that. And for the data analysis application, we can determine peak occupancy times to infer the lot business. And also we can analyze the parking patterns to forecast potential traffic congestion. And the third part of our implementation is the car spot finder. So there are mainly two functions for this finder. So the first one is the spot locator request. Basically, just the user sending a request to the AWS, and the AWS will query the SQL database to see which one is the spot that is vacant and also near the entrance, and then responds with the location of that spot to our user. And the second one is that we all know that sometimes when we go to a big parking lot, we have some trouble to finding our vehicles because it is easy to forget it. So we develop a vehicle locator request. It is very similar to the spot located request. So if you already park a spot in the lot, you can just enter your license plate number, and then we will send that to AWS, and and the AWS SQL database will query it based on the plate number, and then return it with the location of the spot, the parking spot, which is also the location of the vehicle. Thank you.
For the license plate detection and recognition, we have 3 steps here. In the first step, we're going to detect the license plate. To accurately detect and extract the license plates from the vehicle images, we utilize the pre-trained WPartNet model. It is a deep learning model specifically designed for the license plate detection and localization. This figure shows the architecture of the WPartNet. So this system will capture the images via the Raspberry Pi's camera and process them through the WPartNet. Then we go to the step 2. We're gonna use OpenCV to segment the plate characters. Just like these two figures, we segment this figure from this one. Then we go to the step 3. We use some deep learning algorithm combined with OpenCV to recognize the characters. Then we can store the characters into the database.